Hello and welcome to this session. I'm Sylvia Liu from uBlocks, and it is my great pleasure to introduce 4 demonstrations from our 5G ACIA members. First one on the list is 5G AR-based remote maintenance and condition monitoring in the factory environment from Siemens. Then we will see how ultra-reliable time-sensitive network is realized in smart factories from Qualcomm. We'll also hear from ID Lab on how they benchmark wireless TSN solution and verify end-to-end network performance in real time. Last but not least, we will hear from Phoenix Contact's experience with 5G private network and their recommendations for end users. It's a packed session with lots of exciting demonstrations and interviews, so do stay tuned. And now let's start with Siemens to have a look at their automotive showroom and test center to see what they're working on regarding industrial 5G. That's a great video. Now I'd like to welcome Sander Rotmanson, Director of Industrial Wireless Communication at Siemens. Hi Sandra.
Hello Sylvia, thanks for letting me join you virtually.
Great to have you here with us today. So where do you see 5G applications offering the greatest benefits in the industrial sector?
We are just at the beginning of the 5G rollout, Sylvia. At this moment, most use cases focus on remote connectivity with high bandwidth. However, in the future, 5G will enable more challenging use cases, such as plant-wide autonomous logistics and robots becoming cobots. Besides that, industrial 5G will allow users to run multiple different applications over the same infrastructure. All in all, industrial 5G will change the way we make decisions, manufacture products, and maintain our factories.
Some very exciting use cases you list there, Sandra, but when do you think that we will see 5G in real productive environment in the industry?
Starting this spring, the industry will start to benefit from the higher bandwidths that 5G has to offer in remote connectivity applications based on public 5G networks. Industrial 5G routers are just hitting the market. Those products are based on release 15 of the 5G standard. With the in July 2020 release 16 of 5G, the first requirements for 5G on the shop floor are integrated into the standard. However, it will take some time before products based on this standard will hit the market. In addition, we also need to look at connectivity on the shop floor. Here, private 5G networks come into play. These networks are important as it allows users to create 5G solutions focused on their requirements. And it will allow you to create a dedicated network focused on the applications and getting the most out of 5G with low latencies and high reliability.
I believe that we've seen in the trailer already, but just to make sure, is Siemens actively working on 5G products or solutions as well?
Yes, Sylvia, soon we launch our first 5G product. The scale is MUM856-1, an industrial router which is compatible with both public and private 5G networks. On top of that, we're also developing a full private 5G standalone network, creating a full ecosystem from 5G core to end devices. We are testing a prototype in our automotive showroom and test center in Nuremberg to research 5G in a realistic industrial environment. Also, we plan to roll out this prototype solution to some Siemens factories later this year, as well as it will be installed in Hall 9 of the Deutsche Messe Fairgrounds in Hanover.
Yes, the 5G smart venue in Hanover. I heard about that. Can you tell us a little bit more about it?
Of course, Sylvia, the 5G Smart Venue will become Europe's largest 5G test location. We as Siemens will equip Hall 9 with a private industrial 5G standalone network. This network can be used by exhibitors during trade shows, and in between trade shows, companies from small to large can rent this space combined with 5G connectivity to test their industrial products and solutions with our 5G network solution. This is a great way to enable everyone to work with industrial 5G early on.
All very interesting, Sander. Thank you very much for joining us and answering my question today.
It was my pleasure, Sylvia. It's always exciting to talk and discuss innovative new technologies such as 5G and what it can do for industry.
Very interesting, Sander. Thank you very much for joining us and answering my question today. Now let's move to the next demo, where we'll hear from Dr. Yongbing Wei, Vice President of Engineering at Qualcomm Technologies, to see how ultra-reliable, time-sensitive networking is realized in smart factories.
As part of our research and standardization in Qualcomm for 5G industry IoT, we are building our little industry production lines in one of the warehouses in San Diego. We're adding more support, more functionality to support industry IoT applications, such as time-sensitive networking, or TSN. This is a full-fledged over-the-air 5G network with our testing base station and terminals. So our little production line, including a conveyor belt and a couple of major components. On the right-hand side, you have cameras taking all the imagery and send back to our AI vision center. The vision center then analyzes what's going on and send back the direction to PLC. That is used to remotely control the behavior of robots and gates in a very precise time manner. Here's the shot of our industrial test equipment used in our demonstration. There are two metrics we're showing in this screen. On the top is how many objects we have detected and how many objects we have missed. Right now, the TSN is on, everything is fully synchronized, so that all the objects get recognized and taking actions towards. And below, we're showing the metric of time synchronization offset. Right now, because TSN is turned on, the timing error is in the microsecond level. It's precisely synchronized. Now, if we turn off the TSN, and let's see what happened, now you're gonna start to say we're missing more and more objects as a result. And also, very important to look at the time synchronization errors. Unlike before, we are in the microsecond level timing offset. Now it's much, much higher in the millisecond level, which is way beyond the requirement we are looking for. Now, if we turn the TSN back on, then everything back to normal. Now let's turn our focus to reliability. One of the radio technology we're using in the demo is called coordinated multi-point, or COMP, where one device is communicating to multiple points. It's very common in the industry setup or environment where you have a lot of metal structures, either fixed or moving. And when certain radio link paths get blocked, your radio quality will degrade. And that's where the benefit of COMP will comes in. In this case, you can say, even though when this structure path get blocked, there's still other direction signal coming in, create redundancy. That's where we can ensure reliable communications. We have this device. Currently, the COMP is off. There's one pass from this TRP to the device. Right now, everything looks great. There's no blockage. The signal is good. There's no packet error in these plots. Now, what happens if there is a blockage? This is actually what happened in our system, where we use a small robot to pull in a metal sheet to mimic the radio blockage scenarios. What happened as a result of the radio blockage, you're going to see a lot of packet errors. And what if we turn COMP on, and then you can say transmission from multiple TRP points to the device? Even though one of the link got blocked, you still have redundancy from other directions. As a result, there's no packet error, and everything is working as they should be. In some of the use cases, the requirement of reliability is extremely high as 99.9999%, with 6 nines. That means 1 packet loss in 1 million packets. Obviously, we cannot get a very reliable statistic in a short time period. So what we did was we ran a 24 hours run. In the middle of the test run, we bring a blockage. And this is a time lapse of what happened within that 24 hours run. You can see from this chart where when comp is off, we got like 99.9 of reliability, which is not bad, but still far from the desired level we are looking for. With comp turned on, we actually was able to achieve the 6.9 reliability in this test run. In these demonstrations, we're showing 2 new features for 5G, the support of TSN, time-sensitive networking, and the ultra-reliable communications. With these features, we have the opportunity for the first time to replace wired Ethernet cable with wireless and 5G. This is going to open up a huge opportunity for the next industry revolution in terms of flexible manufacturing and productivity increase.
That's great. Thank you very much for joining us, Yongbin. Now let's move to the next one from ID Lab, where we'll see how they benchmark wireless TSN solutions for reliable, time-critical applications in the industrial automation settings. We will also see how the real-time verification of the end-to-end network performance is done, also by ID Lab.
ID Lab is a core research group of IMEC with research activities embedded in Ghent University and University of Antwerp. One of the focus areas of ID Lab is deterministic networking, offering solutions for reliable and verifiable end-to-end connectivity between time-critical applications with really strict quality of service demands. We use our advanced testbeds and prototyping platforms, having features not yet available in commercial state-of-the-art hardware. Time-sensitive networking is a key ingredient for deterministic networks and brings time awareness to all entities in a network.
A key requirement for wireless time-sensitive networking is that it is interoperable with current wired TSN networks. In 5G, this integration is achieved by letting the entire 5G system behave as a single virtual TSN bridge. As part of our research, we are studying the benefits of bringing wired time-sensitive network synchronization and timestamping down to the wireless end devices. We also design new strategies to perform real-time verification of the end-to-end network performance and create tighter interactions between the applications and the network. In the following demo, these functionalities will be shown and benchmarked on top of a small-scale wireless wired TSN lab setup. For the realization of the wireless part of the setup, we use our in-house open-source prototyping platform.
The first step towards seamless interoperability between wired and wireless time-sensitive networks is to enable accurate time synchronization across wired and wireless networks. With our unique time synchronization solution, accuracies around 1 microsecond over the wireless link are achieved. Even in a mixed wired-wireless setup, overall end-to-end synchronization accuracy is typically as good as a few microseconds. It is also important to be able to verify the performance of a time-sensitive network, thus checking whether the network can meet the application's desired quality of service. Currently, quality of service is defined on a traffic class basis. This means that even when the aggregated quality of service performance meets the service level agreement for a specific traffic class, individual applications may still underperform, as is illustrated here. To do better, we designed an expressive and technology-agnostic interface between network and application. Through this interface, individual applications on end devices can express their specific needs without requiring any knowledge about the underlying network technologies. Via the same interface, networks can provide feedback to the application on the measured network performance. But how to achieve such real-time, fine-grained monitoring for verification of the network performance in a scalable way? This is realized by adopting in-band network telemetry techniques in our mixed wired-wireless network environment. With in-band network telemetry, we piggyback monitoring information onto the data packets with negligible overhead. This way, we can collect real-time performance measurements of the actual data traffic on an end-to-end, per hop and per flow basis. We have benchmarked our solutions against commercially available Wi-Fi 6 devices, which do not expose time synchronization features. We have measured synchronization errors above 50 milliseconds up to 120 milliseconds. Our solution, bringing the synchronization accuracy to microsecond level, outperforms this by multiple orders of magnitude.
5G is making significant progress to achieve interoperability with wired TSN networks, which has resulted in new specifications. Nevertheless, it's important to continue to look ahead. In this demo, we have shown the value that can be brought by having end-device synchronization, real-time verification, as well as an expressive application network interface. This brings us one step closer to reliable, time-critical applications in industrial automation settings.
That's fantastic. Thank you very much for joining us, ID Lab. Now, let's see the next video from Phoenix Contact, where they will show us their experience with 5G private networks. We will also hear from them their recommendations for the end users looking at adopting 5G in the factory settings.
For the first time, a cellular technology generation included the needs of automation industries right from the beginning in the specification. The specified 5G features enhanced mobile broadband, massive machine-type communication, and ultra-reliable low-latency communication enable new use cases in all industries and will become the wireless backbone technology for the all-electric society and digitalization. But what are future visions and what is possible today? It's hard to tell those days, but the core element of many future applications are private 5G networks. These networks can be set up and operated isolated from public networks in factories and plants. And the good thing is, they're available today. The private standalone network at the Phoenix Contact campus in Bad Pyrmont, Germany is installed, and different departments are working together to create the perfect usage concept for the company. But what is the motivation? The use cases and drivers to get started with private 5G networks in this early stage.
In our production, we need a very reliable data spectrum. An overloaded radio spectrum can lead to manufacturing downtimes. In our own 5G network, we have the frequencies, the bandwidth and the data prioritization in our own hands. A private 5G network is for us a core technology to enable new cases for the implementation on our shop floor. For example, it makes it easier to integrate AGVs, new robotic systems or scanner technologies into our daily production processes. With the early adoption of 5G technology into our processes, we can already start now to learn and get experiences. By that, 5G can become a core of our infrastructure for future automation projects in our plants.
So 5G is in the starting blocks for the first tests in the production environment. Of course, this requires not only the technology itself, but also the corresponding devices that establish connectivity to the new mobile network.
Basically, any 5G device can connect to a private 5G network if it supports the right frequencies. Commercial-wise, there are some devices already on the market, mobile phones or tablets. In industry, it is a bit different. In summer 2020, Phoenix Contact teamed up with Ericsson and Quectel to design one of the first industrial 5G routers for private networks. With this device, we're able to connect any device with Ethernet on the shop floor into the private 5G network. Besides that, we made really good experience by transmitting Profinet over a private 5G core network from one router to another. In such use cases, we experienced latencies in the low 2-digit millisecond area. And this without any further optimization and based on release 15. As soon as ultra-reliable low latency communication and massive machine type communication are available, we expect that 5G can also be used for safety applications and also for IoT in the industrial area. In the long term, we expect that the effort that we invest now will help us to create the perfect usage concept of our private 5G network here at Phoenix Contact.
In the long term, private 5G networks will reduce the total handling effort because it's just one wireless backbone network which needs to be operated. But how is it for a classic OT company to operate and maintain a private cellular network?
A private 5G network must be able to integrate with the existing network infrastructure in terms of security, management and maintenance. Therefore, a private 5G network belongs to the responsibility of the IT department. It's important to start early in order to gain experience and to develop an operation concept for the productive use. Device management becomes very important as soon as hundreds or thousands of devices are operating within the network. Network slicing is one of the most important features of private networks, but it needs concepts and management effort to run those networks efficiently. Separating the production side, the research and development department, and the customer access is challenging but necessary.
Using all these features and starting early in the concept and trial phases allows us to get ready. Of course, our experience will support customers and partners with feedback, experience, and knowledge to make the best out of 5G.
Thank you very much, Phoenix Contact. Now, I have the pleasure to have Frank from Phoenix Contact with us today. Frank, what were the motivations for Phoenix Contact to install and use your own private 5G network?
Well, Sylvia, Phoenix Contact's production requires a lot of flexibility to handle the dynamics of customer demands, material availabilities, and production capacities. With 5G, we can organize production equipment in a very flexible manner and increase our efficiency. On the other hand, you know that we are developing 5G devices such as routers, PLCs, and many more. Therefore, we need to understand deeply the 5G ecosystems to provide advanced communication functionalities for our customers.
Now, based on your experience with your private 5G network so far, what can you recommend to the end user today looking at adopting 5G?
So one thing we have learned is that even though 5G will be an evolutionary path, there is plenty to understand, to test, and to try already now. We can recommend to end users to start their own journey into 5G already now and to discover the potential of 5G for their own business.
Thank you very much, Frank, for your insights. Great. This brings us to the end of this session. Let me thank again our members, Siemens, Qualcomm, ID Lab, and Phoenix Contact for sharing their 5G journey, experience, and great learning so far. We have a fantastic collection of use cases and demos from 5G ACIA members at this year's Hannover Messe programs, so do please stay tuned, and there's more to discover in the next sessions.